Okay, Algebra 1. Hey, welcome to today's little video. We're trying to speed teach through functions here and learn what functions are. Trying to do multiple lessons in one day. So in today's class, I gave you a packet, and we were able to get through the front and back of the first page, and then we did the front of this next page, doing lessons 2, 3, and 4. 3 days worth of lessons all in one, because this is relatively easy stuff. So just reviewing, part of this is this function notation, looking at something like this and seeing that this is talking about the price for a medium pizza if there's 2 toppings. And then on this side, we have the answer, what the price is. So this whole notation is a way of expressing a whole sentence. This whole sentence fits within this. So we're learning this way of communicating by using this language. It helps us quickly talk about stuff or evaluating them. S of 2 means find the price of a small pizza with 2 toppings. And so, you go through and you do the math for that. And then we had another example with the bowls of ice cream and everything, and also that we can make comparisons between this. Hey, which is a waffle cone with 2 scoops of ice cream? Does the cost of that less than a bowl of ice cream with 4 scoops? So that's what we can say with that. Then we also looked at graphing that with these inputs and outputs like this, that this whole thing is equal to the output. So when we put in -4, so we go here on the graph to -4, the result on this weird shape here is right here, is that -2. Okay, blah, blah, blah. Let's get into the homework. So homework was the front and back of this first page of this packet. Again, doing lessons 2 and 3. I held off on assigning this stuff for lesson 4. I think we'll get there tomorrow. I didn't want to overdo it. So, okay, first one. So we have using the table, this table over here. Just going to zoom in a bit so we get the whole page width. Zooming in as close as we can. Table of X, determining the missing value. So 23. The output is 23 when the input was 5. So we got that. When the input is -5, the output was 17. Okay, the value of the function at what input is -5? Well, we got 2 -5s here, so we're looking for what the input would be. That's right here to get us an output of -5. So -2 is our solution. Okay, looking at this one. So the function f of t, remember that's how we say this. We say it f of t. F of t gives the temperature, so gives the temperature in degrees Celsius, t hours. So we got t for temperature and t for hours. So t is being used for hours. I actually wish that they had done this and called it function c for h hours. I think that would have been a better use of the lettering here, so that so anyway, so that's what it gives us. It gives us the degrees Celsius given some hours after midnight. So midnight comes around and it gets cooler and cooler and cooler, most likely. So we've got this. Select the equation that represents the statement that at 1:30 a.m., that would be 1.5 hours after midnight, the temperature was 20 degrees Celsius. So this is the result, given this as the input. So if that's the input, we want that in the parentheses. And I am seeing this one right here. 1.5 hours gives us 20 degrees Celsius. That's our solution. Moving on to this one, the function notation. So use function notation to represent each statement. So we're going to have, really, for all of these, we're going to have likely something like f of something equals something, where the number here is going to be the degrees Celsius, and the thing here is going to be like the hours after midnight. So at 2 a.m., okay, hey, 2 a.m. The temperature at 2 a.m., right there, the temperature at 2 a.m. We don't know what the temperature is, so this would be all that we write, f of 2. The temperature was the same at 9 a.m. and at 11 a.m., so that's okay. So that's saying that the temperature at 9 in the morning is the same as the temperature at 11 in the morning. That's how we'd express that. It was warmer at 9 than at 6 p.m. right there. So we've got noon would be 12 o'clock plus 6 more hours. That would give me, so 6 o'clock in the evening, p.m., would be 18 hours altogether. So when I write this, it's talking about 9 a.m. and it's also talking about 18 hours after midnight, and it's saying that this was warmer than that, so I have to have the alligator eat that one. That's our expression. Sometime, oh man, we don't know. Sometime after midnight, the temperature was 24 degrees. So we know that it's 24 degrees Celsius. We know that part, but we don't know the time. So what do? We just say f of t, some variable that represents some time that we don't know. All right, those are all our answers. A restaurant sells 3 different salads. Okay, so we've got this. Use the functions c of x, g of x, and p of x to represent the price of a Caesar, a garden salad, and a pasta salad. Love it. Okay, CGP, Caesar garden pasta, with X additional ingredients. So the Caesar salad is made as it's made, with croutons and the salad dressing and the romaine lettuce and the cheese. But what if you wanted to add an extra topping on top of that? Well, that's going to cost extra. So when we look at this, G0 means, so this means explain the meaning of this. I'm not going to write all these down. I'm going to say it out loud. This means that a garden salad with 0 toppings will cost $10. That's what I would write. What does this say? This is saying a garden salad with 3 toppings will cost more than a Caesar salad with 1 topping. That's how we take that whole thing and phrase it. And a pasta salad with 2 toppings will cost less than a garden salad with 3 toppings. There we go. Okay, so that is the first page, now the back. And, okay, so we've got f of x is equal to 2x plus 5. Now this is a rule, and we can change the value that we're inputting in and follow this rule to find the value of the function. Calculate the value of the function. Notation expression, the first value has already been completed for you, so f of 0, what did they do? They put a 0 in here and did 2 times 0 and then added 5. 2 times 0 and then added 5. 2 times 0 is nothing. You add 5 to that, you get nothing, so 4. Okay, so this means to find f of 4, we're going to take the x value is a 4, we're going to do 2 times 4 and then add 5 onto it. Well, 2 times 4 is 8. And 8 plus 5, well, that's 13. Okay, so the value is 13. 6, same thing, we're going to do 6. 2 times the input of 6, and then add 5. 2 times 6 is 12, and 12 plus 5, that makes 17. And the last one, -3, we're going to do 2 times the input value of -3. All we're doing is just following this rule. And so that would be a -6, but we've also got to take and add 5 to that. So -6 and 5 makes a -1. Those are our 3 answers, the values of the function given those inputs. All right, we got a toy factory, makes toy bunnies. Each toy bunny holds a carrot. Okay, so I don't know, we got a little bunny. Is this going to be like a bat or a bunny? I don't know. I don't know how to make a little bunny. That's a little bunny. All right, but it's holding a little like carrot. Okay, so it's holding like a little carrot, and it says the bunny's height. The bunny's height is h of x is 3 times the length of the carrot, x. So this height of the carrot is x, and the height of the bunny is 1, 2, 3 of those carrots tall, 3x. Okay, not crazy. That's the rule for this. That's my weird demented bunny. And so what we're doing, we're taking each of these x's is how tall the carrot is, and we're multiplying it by 3. 2 times 3 is 6, 3 times 3 is 9. If the carrot was 4 centimeters or inches high, then we do 4 times 3 to find the bunny is 12 inches or centimeter high, 15 and 18, and we're done. Okay, write an equation for this function. Yes, the equation I already wrote is h of x is equal to 3x. Hopefully you got that. Good job. All right. Now the functions f of x and g of x are defined as these. So this is not a separate problem, okay? And go from 2 to 3, the separate problem, not this. This is one rule, this is another. Both of them use the inputs of x, but we're going to do different operations to them. So what's f of 2? f of 2 means put a 2 here, and 2 times negative 15 would be negative 30 plus a positive 80. The result of that would be 50. How do we write our answer? We can't just write that. We have to write that when we put the input of 2 in the f function, we get 50. That's our final answer. How do we find g of 2? We do the same thing over here. To get g of 2, we put a 2 in for that x and do 2 times 10 to get 20. And then we add that 25 onto it. So again, we put a 2 in here, multiply, and we get that 45 is the result of this g function when we put 2 into it. Two different answers, two different ways to show that we get those answers. All right, and function p of s gives us the perimeter of an equilateral triangle with side length s. Well, we got that word, equilateral triangle. That means that you have a triangle and all three sides are the same length. They are s, s, and s, not to be confused with the number 5. Okay, so to find the perimeter of that, that's going around the edges and adding up that distance around the edges, we're going to do 3 times s. That should make sense. This is the rule for it. What is the value of p of 20? And what does the answer mean? Okay, so p of 20 just means we take this, and where the 20 is, we put it where the s is. It means 3 times 20. And so its value would be 60. What does that mean? You take this part and put it into a sentence. This means the perimeter of an equilateral triangle with, oh my God, we got to keep going. We got to work that 20 in there. And what is the 20? It's a side length. With a side length of 20 inches, feet, meters? It doesn't say, does it? 20 units is equal to, so what is equal to that? The perimeter of is equal to 60 units. That absolutely should make sense. This is not one that's meant to be like crazy hard. It's more, can you write the notation and then can you interpret that as an answer? This is a super basic problem. 20 plus 20 plus 20 is 60. We're multiplying by 3. It's meant to be an exercise in using this notation. All right, so I hope that made sense for you. This was our first day working with function notation in this way. And, well, we got partway through this packet. We'll see you tomorrow. Bye.